Hey guys, this is going to be pretty much our last topic before I introduce our summative task. But this topic we may actually spend 2 weeks on this. I'm not too sure. We'll have to see how it goes, okay? So we're going to be going back to word problems this week. We did a little bit a few weeks ago, identifying independent, dependent variables, finding the slope, finding the y-intercept. Remember that stuff? So we're going to be starting off same idea, okay? So here we're going to have some word problems, and we're going to have to not only come up with an equation, but actually take the equation and then solve something, okay? So there's different types of word problems, 4 different types. I'm going over type 1 right now. Type 1, right, where we would work with a slope-intercept form equation. Okay, sometimes we work with standard form equation. Remember, there's 2 forms to the linear equation, slope-intercept and standard. Okay, so we're going to want to use this method. We're going to use this method when the question that we're reading, when the question gives a rate of change, which is our M, remember M, and it also gives us a starting point. Remember initial value? Starting point and initial value mean the same thing, okay? Initial value. And remember that is our B. Okay, maybe I'll put those in different colors, right? We have our M and our B, okay? So we're gonna use this strategy whenever the problem we read gives us rate of change and gives us the initial value, okay? So let's just look at the first problem here, okay? So it says Evan is going to the county fair this weekend. The admission to the fair is $5 and the cost per ride is 50 cents. Okay, these first few sentences, this is going to help us build the equation. Okay, so after we build the equation, we have to go further. So it says if his parents gave him $20, write and solve a linear equation to find out how many rides he can go on. Okay, so it's like there's 2 parts to this equation. So part 1 is coming up with our equation. So we're going to use the highlighted information. Okay, so first of all, what are our 2 variables? Well, the variable is going to be, we have cost, right? Cost, and we also have number of rides. Okay, so which of those is our independent variable? Or which of them is our dependent variable? Well, remember, cost will depend on the number of rides. So that means that cost is our dependent variable, which is our y, right? And number of rides is our x, okay? So first, let's identify the rate of change, okay? So first of all, m, what is m given to us as? Well, if we look at the cost per ride, it tells us that it's 50 cents, okay? So now remember that the other money we're talking about is in dollars. So I'm going to write 50 cents in terms of dollars, okay? So my rate of change is $0.50, right, which is 50 cents per ride, okay? Now, what's our initial cost, our initial value? Well, it says the admission to the fair is $5. So right away, when I get to the fair, I have to automatically pay $5. Okay, so we're going to use this information to create our equation, right? So we have y, which is cost, is equal to 0.50 times the number of rides, which is X, plus $5, right? And notice how I don't have to put units into my equation, okay? I just put the numbers in, all right? So that's part one, coming up with the equation. Now we're going to solve the equation. So we're going to move on to part two, okay? So his parents give him $20. So with $20, how many rides can he go on? Okay, so we're given the cost that he can spend, but we don't know how many rides he can go on. Okay, so which of the two variables are we given? Remember, our variables are cost and number of rides, right? Well, cost is 20, right? So it's telling us that we can set our y value to equal to $20, right? So let me do that. So set cost to $20, right? And that means make y equal 20, okay? So that's what we're going to do. We're going to substitute y equals 20 into the equation, okay? So look, we have $20 to spend, okay? We know that it cost 50 cents per ride, so 50 times the number of rides, plus the $5 entrance fee, okay? So what do you think we're going to have to do with this in order to figure out how many rides she went on? Well, remember, the number of rides is our X. We want to figure out X, okay? So what we're going to do is we're going to solve for the number of rides, right? And that means solve for X, right? Okay, so let's take this linear equation and let's start to rearrange it. So the first thing I'm going to do is I'm going to pick up this plus 5, and bring it to the other side, right? Because I want to isolate the x. So I'm going to have 20 minus 5 is equal to 0.50 times x. That's going to give us 15 is equal to 0.50x. And then we divide both sides by 0.50. And that is going to give us x is equal to 30 rides. Okay, so that's our final answer, right? So with $20, Evan is able to go on 30 rides on the county fair. Okay, so that would be our final answer. Okay, let's try another example. Okay, so again, I'm going to take it slow because I understand the word problems can be tricky. Okay, so let's read through the problem. Question 2. While visiting Crimson Lake, Sally decided to go kayaking. The rangers, so the people who rent the kayaks, they charge $8.50 per hour in addition to a $25 deposit to rent the kayak. Okay, so this is the information we're going to use to create the equation. These first sentences. Okay, we're going to use that to create an equation. And then we're going to answer an additional question. We're going to say, if she rented the kayak from 11:30 a.m. to 2:30 p.m., write and solve a linear equation to find the total cost to rent the kayak. All right, so let's just deal with the first part. Let's create that equation. Okay, so first of all, let's figure out what are our two variables. What is x? Oops, sorry. What is x and what is y? Okay, so again, we know we want to find the total cost. Okay, so cost is our dependent variable. Okay, now what affects cost? Well, it says the cost changes $8.50 per hour. So the number of hours is our independent variable. Okay, so what is our rate of change? M. Rate of change is $8.50 per hour. Okay, remember rate of change always has 2 units. B, what is our initial cost? So even before she kayaks, she has to pay this initial $25 fee, right? So that is her initial value. Oops. $25. Okay? So with this information, we can now create our equation. So cost is equal to $8.50 times the number of hours plus the $25 deposit. Okay? So that is our equation. Now let's move on to the second part of the question where we're going to have to solve this equation. Okay? So if she rented the kayak from 11:30 a.m. to 2:30 p.m., write and solve a linear equation to find the total cost to rent the kayak. Okay, so what are we given in this problem? Are we given X or Y? Well, we're asked to find the total cost. So that means we're not given Y. We're going to have to find Y. What we are given is the number of hours she's kayaking. Okay? So if she kayaks from 11:30 in the morning to 2:30 p.m., that means she's kayaked for 3 hours. Okay? So what we're going to do is we're going to let X equal 3. Okay? And then we're going to solve for the cost, which is our Y. Okay? Now, luckily, when we're solving for Y, we don't have to do any rearranging like we had to do in the first problem. Okay? So here we have the equation Y is equal to 8.5 times 3, because she kayaked for 3 hours, plus the $25. All right? So that gives us 25.5 plus 25, which will give us a total cost of $50.50. Okay? So therefore, the total cost of to rent the kayak for 3 hours, right? Sally must pay $50.50. Okay. There you go. Oh, we didn't write a concluding statement for the first one, kind of because I ran out of room, but we would write a concluding statement. So for the first question, so therefore, given $20, what's his name again? Evan. Evan can go on 30 rides. There we go. That was just forgot to do that. Okay? There we go. So that is example 2. Okay? And keep going. Okay, keep going till you kind of get the hang of it. All right? So Alex bought a new truck for $42,935. According to the dealer, the truck will depreciate approximately $4,200 per year. Write and solve a linear equation to find how many years until the car is worth $5,135. Okay. So again, to create our equation, we are going to use the first pieces of information. Okay. Then later we'll deal with the rest. Okay, so let's just start with our equation. So first things first, right? What is our x? What is our y? Okay. Well, first of all, I want to explain a couple words actually. The truck will depreciate. What does that mean? It means the cost, the value of the truck will go down, right? And that makes sense because every year that you own a car, it's worth less money, right? Okay, so that means according to the dealer, the truck will depreciate, meaning the value of the truck will go down by approximately $4,200 per year. Okay, so our y, our dependent variable, is the value of the car. Value of car. So, or truck, sorry, I guess. Might as well be consistent. Value of truck. Okay, so that means how much money is it worth? Okay, now what affects the value of the truck? Well, according to the dealer, the truck depreciates at approximately $4,200 per year. Okay, so that means our independent variable is the number of years. Okay, so now let's find our M. What is our rate of change? Okay, well, we see this. Okay, it depreciates. This key word is very important because what it tells you is it tells you our rate of change is negative. It's going down. So when I write my rate of change is really negative $4,200 per year. Okay. In my B, well, what's the initial value of the truck? Well, it says that Alex bought a new truck for $42,935. So, I mean, that's our initial value. So, 42935. So now let's take this information and let's create our equation. So y is equal to negative 42,000 times x, which is the number of years, plus $42,935. Okay, so that means that every year the price will go down by that much money. Okay, so now let's move on to the second part of the question. Okay, so write and solve a linear equation to find out how many years until the car is worth, let me just erase that because I've written way too much, gone over this again and again. Okay, so until the car is worth $5,135. Okay, so let's pause there and let me ask you, okay, are they giving us X or Y? Well, remember, X is the number of years, Y is the value. So they're giving us Y. Okay, so what we're going to do is we're going to let Y equal $5,135. And what we're going to do with that is we're going to solve for the number of years. In other words, solve for X. Okay, so there we go. So we're putting in so y is equal to $5,135. And we want to figure out how many years will it take for the car that was originally $42,935. How many years until it's worth $5,135? So negative 4,200 times x plus 42,935. All right, so again, we are solving for x. So we're rearranging our equation. I'm going to pick this guy up. I'm going to bring it over there. So I get 5,135 minus 42,935 is equal to negative 4,200x. Okay, now need to do some calculations. Okay, I'm sorry, I just had to, oops, sorry guys, I just had to go grab a calculator. Anyways, okay, 5,135 minus 42,935. We get negative 3,700, negative 4,200. Okay, now divide both sides, right, to get x all alone. And that gives us x is equal to 9. Okay, that's nice. So my concluding statement, therefore, it will take 9 years for the car or the truck to be worth, $5,135. Okay, so don't forget the concluding statement is important. Okay, you have to relate the problem back to the the answer back to the problem. Your answer can't just be x equals 9, because what is x, right? You have to say in your problem statement x is 9 years. Okay, or sorry, your concluding statement. All right, let's try the next one. So if you buy a car wash at a gas station for $6, the cost per gallon is $2.35. Okay, so again, there's our information to create an equation. Okay, second part of the question says, if you have $40, write and solve a linear equation to find the number of gallons of gas you can afford. Okay, so let's start it off identifying our variables, our x and our y. Okay, so y is our cost, okay, total cost of gas, okay, in dollars. And what affects the cost of the gas? Well, cost per gallon, so the number of gallons. Gallons is just the word, instead of liters or something, it's just a unit of measure that they use in the United States, if you're curious. Okay, so x is number of gallons, y is total cost. What about m? What is our rate of change? Okay, well, our rate of change, it says it's $2.35 per gallon. Okay, and b is our initial cost. Well, our initial cost we pay is this $6. Okay, so again, let's use this information to create our equation. Y is equal to 2.35 times X plus that $6. Okay? So let's go over the second part of the problem again. If you have $40, write and solve an equation to find the number of gallons of gas. So what is it? Is this problem giving us X or Y? Is it telling us the number of gallons, or is it telling us the price we can spend? Well, it's telling us the price we can spend, and it wants us to figure out the number of gallons. Okay, so that means we are given Y. So what we're going to do is we're going to let Y equal $40. And we're going to solve for X. And X is the number of gallons, right? Okay. So 40 for Y. Right? And then again, we're just rearranging, isolating for X. So I'm going to bring that 6 over. It's going to be 40 minus 6 is equal to 2.35X. That gives us, 34 is equal to 2.35X. And then finally, divide both sides by 2.35. Gives us an X equal to okay. It gives us an X equal to approximately 14.5 gallons. Okay, I rounded. It's 14.468, so I'm just going to round to 14.5. Okay, so now we write our concluding statement. So therefore, if I have $40, right, I can afford 14.5 gallons of gas. Okay. All right, so those 4 questions have to do with us using the equation, the linear equation in slope-intercept form. Okay. So now we're going to move on to type 2. Okay, type 2 of problem solving with linear equation. So this is where instead of working with something in y equals mx plus b, and I'll just write that, y equals mx plus b, instead of it having it in that form, we're going to solve an equation that is in standard form. Remember, standard form is there's some a times x plus b times y is equal to c, where a, b, and c are just numbers. Okay, hopefully you remember this because we did lessons on this. Okay, so when you'll use the standard form to solve an equation, right? Obviously, if you're given rate of change and you're given initial value, it makes sense to use slope intercept. But if you're not given those two things, you have to come up with a different way. Okay, so we're going to use the standard form of the equation when we come across a problem that relates two different objects. So when the problem relates two different objects. Okay, so you're going to see what I mean by that. Okay, in a second here. Okay, so let's read the first question. Question 5. Sam ordered 2 hamburgers and 3 hot dogs from the concession stand at the baseball game. His bill came to $19.05. Okay, so I'm going to use this information to create an equation, okay? And then we'll use the rest of the information later, okay? So remembering, we still have to figure out what our x and our y is, okay? So here we're relating the price of two different objects. We're relating the price of hamburgers and relating the price of hot dogs. Okay? So it doesn't really matter here, independent, dependent. We kind of just it doesn't particularly matter which variable we assign to x or y in this scenario. Okay? So I'll just go with x is going to equal the cost of a hamburger, okay, and y will be the cost of hot dog. Okay, now let's create our equation. Okay, so we know that total cost is 1905. Okay, so we know that we're going to have something equals 1905. We know that he bought 2 hamburgers. So he bought 2, and the cost of a hamburger is X. Okay, so he bought 2, so he spent $2 on hamburgers. Okay, he also bought 3 hot dogs. So he bought 3 times the cost of a hot dog. Okay, so this is our standard form equation, right? It's in the form AX plus BY is equal to C. So this is our standard form equation. I'm just going to move it to the side so I leave myself a bit more space here. Okay, right? Standard form. So it's totally different problem solving. Okay, let's read the rest of the question. So if hamburgers cost $5.25 each, write and solve a linear equation to find the cost of each hot dog. Okay, so with this information, we have to ask ourselves, what are they giving us? Are they giving us X or are they giving us Y? Okay, they're giving us the cost of a hamburger. And I said hamburger would be X. So I'm going to say let X equal $5.25. Okay, and we're going to do that and we're going to solve for Y. And remember, Y is the cost of hot dog. Okay, so it's simple as it is, okay? So we're going to go 2, replace the X with 525, plus 3 times Y is equal to 19.5. Now, let's keep going. Let's simplify. So 2 times 525 is 1050, plus 3Y is equal to 19.05. We get 3Y is equal to 19.05 minus 1050. And then finally we get, or not finally, but we're going to get, let's see, 1905 minus 1050. We get $8.55. Divide both sides by 3. And I get a hot dog cost of $2.85. Okay. Right? So therefore, the cost of each hot dog is $2.85. And we can test that. We can test that. We can go back and sub it into our equation, right? So if we put in 2 times the price of a hamburger, which is $5.25, so 2 times 5.25, plus 3 times 2.85, and that comes to $19.05, right? So if I sub X equal 5.25 and if I sub Y equal 2.85, I will get 19.05. That's my answer. So there's an easy check to make sure you're correct. Okay? Let's move on to question 6. So same thing, we're dealing with problems that relate to different objects. So in the first one, we were relating the price of hot dogs and hamburgers. Okay. Tickets at a school play cost $4 in advance or $5 at the door. The total ticket sales for an evening production were $440. If no tickets were sold in advance, write and solve a linear equation to find how many were sold at the door. Okay, so again, we're going to use the first few sentences to create the equation, and then we'll deal with the second half of the problem later. Okay, so here we're relating two different objects. We're relating the cost in advance, we're relating the number of people who bought tickets in advance to the number of people who bought tickets at the door. Okay, so again, it doesn't matter here in this specific problem, it doesn't matter which one I call X or Y. So X will be the number of people. No, hold on. I have a better way to arrange that. I'll just say number of tickets. Wow, I didn't spell that properly. Tickets sold in advance. Oh my God. Okay, sold in advance. And Y will equal the number of tickets sold at the door. Okay, so let's create an equation. We know that in total, the ticket sales came to $440. So that we know we're going to have some sort of equation equal 440. Remember, we're trying to come up with AX plus BY is equal to C, where C is some number, okay? So here we just found our C, right? We know that in total, it should come to $440. Okay, so if X is the number of tickets sold in advance, then $4, 4 times X, will equal the amount of money they made by selling those tickets. Okay, hold on. Oops. Right? So $4, oops, I didn't mean to do that. Oops. So $4 times X plus, it's $5 at the door, so $5 times Y. So if let's say I sold 10 tickets in advance, it would be 4 times 10, right? And if I sold 50 tickets at the door, it would be 4 times 10 plus 5 times 50, right? So this is going to be our standard form equation. Okay, just going to move that over as well. So again, we're going to use the second part of the problem to now solve the equation. So if no tickets were sold in advance, write and solve a linear equation to find out how many tickets were sold at the door. So again, let's ask ourselves, what are they giving us? Are they giving us X or Y? Well, they're saying no tickets are sold in advance. So that means that X, right, we have to let X equal 0 because we didn't sell any tickets in advance. And we're going to use that to solve for Y, which is the number of tickets sold at the door. Okay, so we go ahead, 4 times 0 plus 5 times Y is equal to 440. Remember, anything times 0 is just 0. So we end up with 5Y is equal to 440. and then dividing both sides by 5, we are going to get, let me see here. So 440 divided by 5, we get 88. Okay. So what that means, if no tickets were sold in advance, 88 tickets were sold at the door. Okay, there you go. All right, question 7. So Karen's piggy bank has all dimes and all quarters. Find the total value of the money in her the total value of the money in her piggy bank is $11.40. Okay, so let's use that information to come up with our equation. And then we'll deal with the second part. So again, remember when we are relating two different objects, so here we're relating dimes and quarters, okay? So it doesn't matter which one I say is x, okay? I'm going to let x equal the number of dimes, why not? And I'm going to let y equal the number of quarters. Okay. So now I have to come up with my equation. Well, I know the total value is $11. Oh, don't put units in the equation. So is equal to $11.40. Okay. Now, what is the value of one dime? Right? So the value of one dime is $0.10 times x. Right? The value of a quarter is $0.25. Okay? So this is our standard form equation. So if we have 100 dimes, let's say we have 100 dimes, and we multiply it, that would be a value of 100 times 0.10. Okay? So let's move on. So the question says, if Karen has 36 quarters, write and solve a linear equation to find the number of dimes. Okay, so again, is it giving us x or is it giving us y? Well, I said that quarters was y. So what we're going to do is we're going to let y equal 36 and then just solve for x. Okay, so 0x plus 0.25 times 36 is equal to $11.40. Okay, so if I have 36 quarters, 36 times 0.25 is equal to $9. So if I have 36 quarters, that's equivalent to $9. Okay, now I'm going to isolate for x. So 0.10x is equal to 11.40 minus 9. 0.10x is equal to 2.40. Okay, and then we're going to do our last step where we divide both sides by 0.1. So 2.40 divided by 0.1. And that means I have 24, not 25. Okay, 24 dimes. Therefore, Karen has 24 dimes in her piggy bank. Okay, so the Oakville High School Marching Band sold gift wrap to earn money for a band trip. Solid colored gift wrap sells for $3.50 per roll. And printed gift wrap sells for $5 per roll. The band needs to earn $2,500 for an upcoming competition. If the band sells 325 rows of the printed paper, write and solve a linear equation to find the number of solid paper they must sell. Okay, so again, I'm just going to highlight the information that will help us create the equation. Okay, so there we go. That's it. That's what we need for the equation. So again, now we need to define x and y. So again, we're comparing two things. So here we're comparing colored gift wrap and printed gift wrap. Okay, so it doesn't matter. I'm just going to say let x equal color gift wrap. Okay, and then y can be our printed. So maybe printed means there's some sort of pattern on it. Printed gift wrap. Okay, so now all I have to do, is, oh geez, you know what? I made a mistake. Because x and y are not just colored gift wrap or printed gift wrap. Let me erase that. I don't like this. I'm going to change that. Okay, so let x, the number, so x is the number of color gift wrap sold, right? And y is the number of printed gift wrap sold. Okay, it's important to make this distinction, okay? The number of colored gift wrap sold. Okay, so we know that solid gift wrap sells for $3.50. So $3.50 times the number of gift wraps I sell, so times x, and then the printed gift wrap sells for $5. So $5 times y, so times the number of printed gift wrap sold. And we're told that the band needs to earn $2,500. Okay? They need to earn that much money to be able to go on their trip. Okay? So here is our standard form equation. Now, right, let's move on to the second part. So if the band sells 325 rolls of the printed paper, write and solve a linear equation to find the number of solid paper they must sell. Okay, so again, are they giving us x or are they giving us y? Well, I said the printed was y. So you may have put x as printed wrap paper, it doesn't matter. So I put y as my printed wrap paper. So I'm going to say let y equal 325, solve for x, which is what we want to find, the number of solid paper. Okay, so 3.50 times x plus 5 times 325 should be equal to 25,000. So keep going, keep simplifying. So 325 times 5 is 1,625. Okay, we're going to keep rearranging. So bring that over to the other side. we're going to get 3.5 times x is equal to 250 minus 1625. So if I subtract that, I'm going to get 875. Last step, right? Divide both sides, by 3.5. That's going to give me an x equal to 250. Okay, 250. So my concluding statement, right? So therefore, the band must sell 250 solid paper rolls. Okay, honestly, I think I'm going to stop the video here, and I'm going to maybe take a break and come back in a second video and do type 3 and type 4. I just need a break because this lesson is getting pretty long. Okay, so there will be a second part to this lesson.